Hello guys, programming homework 1 is what we will be discussing today. I will read off the prompts given to us, or the questions given to us, and then I will show you my code and how I worked it. And the resources I found that helped me make the code that you will see here shortly. So question 1 says, financial application, compute the future investment value. Write a function that computes future investment value at a given interest rate for a specified number of years. For example, future investment value is 10,000 at a rate of 0.05 divided by, 12 months, and the time span of 5 years returns 12,833 with 59 cents. I think it's a two-part because we have to do that first function right there, and it says write a test program that prompts the user to enter the investment amount and the interest rate, and then print a table that displays the future value for the years 1 through 30. So we'll hop right into that first question, and I've already written the code in advance. It's what you see right here. So I did import the math function, but ended up not, or I guess I did with the round, but you'll see how I changed it a little bit. The resources I used were this website right here, which I will show you in this page. All I did was look up the compound interest formula. I grabbed the compound interest formula and inputted it in my code. I started by defining my function, which I named financial application, with the three arguments that I have are the initial value, the rate, and the years. These will go in as we input them later. So I started off by doing the formula for the compound interest, which is right here, which I assigned to the variable future val, which equals the initial value times 1 plus the rate, 1 plus the rate elevated to the power of years times the months. So I did not use the mathpal function or thing because I kept let's just say I ran into problems, so I found this on the internet. You could use 2 stars as a power. And then I told my function just to print out the investment value after years is future value, and I rounded it with this round function to the 2 decimal places. So as we can see here, I have the financial application. I inputted $10,000 or 10,000 as my initial value. I gave it the rate, which is 0.05 divided by 12 months over a period of 5 years. So we'll go ahead and run this and see what it gives us. So as you can see here, it gave us that the investment value after 5 years is 12,833 with 59 cents. So we'll go back over to homework, verify that that is correct, and it gives us the same exact value. So I assume that my function has worked for what they require over here. Now the second part says to write a program that prompts the user to enter the investment amount and the interest rate. So we'll need to create, or I decided to create another function that allows for user input, and changed up a little bit of the function I used because we are only accepting 2 arguments this time instead of 3. And also we are creating a table, so I'll go ahead and switch over and show you guys that. Come back over to this. I made this program called financial app table, which accepts 2 arguments, initial value and rate. So I kind of have a variable that that I assign the function that I will be using. It's almost the same one as I used previously. I just changed a couple of things. Since the rate was not given to us in decimal form, I inserted this rate times 0.01 to convert it to a decimal. I also, instead of years, I put I because I will be using a for loop in order to get the years from 1 to 31. So it's practically the same. I did print year I, which is going to be the year, the number of the year, is, and I again use the round for my variable value, which will give us a future amount of rounded to the 2 decimal places. So down here I added a couple of things. I added the input value for amount, which is what we are going to input. I put in here enter the investment amount. So it'll prompt us here shortly to enter that investment amount. It will also prompt us to enter the rate, which I have right here. It tells you to put the rate as shown right here, given an example as maybe 8%, because as we can see in our homework, it says that they're gonna put it with a percent sign. So I went ahead and gave an example so the user who's using this can go ahead and put a percent sign as well. So I came back over here and I put rate, and I went ahead and took off the percent sign in order for me to change the string into a float, which will help me with the math, which will help the computer compute the math. So I went ahead and replaced the percent sign with just a blank, practically just removing the percent sign from the number. I then changed rate to a float, and then I did a for looping statement. So for I in range 1 through 31, so one number exceeding because it doesn't reach 31, so it'll be 1 through 30, we will run the financial application with the amount given and the rate given too. So we'll go ahead and run this and see what it'll give us. Oops. Okay, so it immediately prompts us to enter the investment amount. I'm going to use the investment amount that was given to us here in the homework. The investment amount says to type in 1,000 with a 9% return, and let's see if it prints out our table. So I'll go ahead and do print, or actually go ahead and type in our investment amount, which is 1,000. Go ahead and enter our percent, which is 9%, and sure enough, there it goes. It ran us through. Not only did it give us the year, but it also gave us the amount per that year, which is good, rounded to the 2 decimal places, which looks a lot cleaner. So it ran us through. We'll try it again with a different percent to make sure it's not popping up the same number. So we'll run it again. Investment amount, I'll give it a 25,000, or yeah, 2,500 with a 8% rate. Alright, looks like the numbers did change, so we're doing good. So I believe this function works. We'll go ahead and go on to our second question, which, oops, I guess I left you guys over there. So I'll go ahead and run this again. I don't know how much it explained that wasn't on our video over there, but I'll give it a rundown again. So yeah, I made this. We'll go ahead and test it with the numbers given. So we'll run the financial table application. Investment amount being 1,000. the percent being, or the rate being 9%. And it went ahead and gave us years 1 through 30 and the amounts for each year. Rounded to the nearest decimal place. I see that in some places it doesn't have, or just 1 decimal, probably because it's a 0. No biggie, but seems to be working fine. I'll run another test with different numbers. 2,500 at an 8% return. Alright, seems to be working. So, as I said before, I'll go on and do question number 2. So go back to the other screen. Question number 2 says, make a prime function. Make a function for testing whether a number is prime. Use this function to find the number of prime numbers less than 10,000. So again, we'll jump over to our other side, and then I have the prime function right here. Now the prime function kind of stumped me a little bit, but what helped me understand, I went online, I have this website, the resources, so I'll show you guys right now. I'll probably butcher this, but the Sieve of Eratosthenes helped me quite a bit, not only looking at this little diagram, but they also have a pretty good explanation within here, and they have pseudocode, which really helped me out when I was coding this. So it practically says that, or what I understood from it, is that it takes a number, verifies if it's prime. If it is or not, it marks it as is prime as true, and then it goes from that number on consecutively. So 2, add 2, 4, and each number after that, just stepping 2 as not prime, because 2 will go into that number, and then it repeats that number after number after number till it gets the number that we had given it, to the extent of the number we had given it. So it then goes back and rereads the numbers, and every number that it marked as is prime, that is still true, because each number that has a number that goes into it will be marked false, and that every number that did not have a number that went into it would be marked true as this prime. It goes back and collects those numbers and then prints them out. I don't know if my explanation is very confusing, but it took me a while to understand. So we have right here, I'll go over to the other page so you guys can see. I have right here my code. I only imported one thing, which is import math, to use the round and to use the square root function. So I have right here if prime, if number, which is going to be the number we put in. If number is less than or equal to 2, return a blank, because there's only 2 numbers that are prime, which is 1 and 2, and we already know that 1, so I went ahead and right here set number 1 as false, so, or number 0 in the array as false. In this first little line, I assigned every number from the beginning to the number we had given it, inputted in the arguments, as true, stating that every number in the beginning is prime number. It then goes into this, which will, as I explained, go through the numbers and assign numbers that have factors as false. Therefore, in the end, having this return variable will only give us the numbers that are still marked as true once the code goes through every number. So I tested with the number 10 just to see if it would work, because we all should know or can figure out which numbers are prime from 1 through 10. So I ran the code, I click run, and it gave me number 1, number 2, 3, 5, 7, and 9, and I think that's, hold on, give me a sec. We know that 9 is not prime, so I'll have to figure out, let's see, maybe set is prime the number 1. to false. Let's run this again. So I must have done something wrong, but so far this is what I have gotten. So I'm not sure why I marked it when I typed in a 10, but when I typed in 10,000 it did not mark 9 as being prime. So don't know if that was just an error of mine or... Let me type 11 to see if that works. That's odd. Well, as we can see, it works with larger numbers. Don't know why I marked 2. I'll have to do some more troubleshooting, but yeah, that is my prime less than a number function. We'll go over to the square root function, which I'll read first in our programming homework. Question number 3 states that, or says, math, approximate the square root. There are several techniques for implementing the square root function in math class. One such technique is known as the Babylonian method. It approximates the square root of a number n repeatedly by performing a calculation using the following formula. Next guess equals last guess plus last guess divided by 2. When next guess and last guess are almost identical, next guess is approximated square root. The initial guess can be positive, value 1. This value will be the starting value for last guess. If the difference between next guess and last guess is less than a very small number, such as 0.001 or 0.0001, you can claim the next guess is the approximated square root of n. If not, next guess becomes last guess, and the approximation process continues. So, I had a little bit of trouble. I first looked up the Babylonian method, which I referenced over here. Let me switch over so you guys can see. I have my reference, my reference right here. I'll go ahead and show you guys what that states. And it also came out to be pretty handy that I looked it up, because it also had an example of what we could use inside of Python. So it states right here that practically you get a number, or I'll speak about it in the code so I can show you guys. So as our homework stated, and as my reference or resource states as well, we have our last guess, which is our number that we're going to input. So if we, for example, enter the number 12, last guess would be 12, next guess, I'm going to set this actually to 1 because that's what the homework said. And if it has a difference of this small number, 0.0001 or 1/10,000, then it will stick with whatever guess is there. So the function works like this. While it's a looping function that keeps on changing last guess and next guess till they're almost identical until there's a difference of the number stated before. So we'll take last guess minus next guess is greater than the difference. So last guess, in this being 12 minus 1, is greater than the difference, which is this small number. Then it does this loop. Last guess will be last guess plus next guess. So it'll do 12 plus 1, then it'll divide that by 2. So 13 divided by 2 gives us a rough 6.5. So 6.5 as last guess. So it assigned a new value to last guess, which is 6.5. Next guess will then be the number we inputted, which was 12, divided by the last guess. So the last guess just changed. Last guess is now 6.5. So I'll take out a little calculator right here. put 12 divided by 6.5. Oops, you guys don't see my calculator. Let me share my first screen. Screen 1, display 1. There you go. Calculator, so I'll start it again. 12 divided by 6.5. Oops. No, that's right. So that's the number that will go into next guess. So this number right here, I'll keep in the calculator. I'll minimize that. So my last guess is now 6.5, and my next guess is on my calculator as 1.8 or something like that. Let me check. Yeah, 1.8 and some numbers. So it repeats it again. So last guess, which is 6.5 now, minus 1.8. If it's greater than the difference of the small number, it'll keep doing that loop until it gets to a smaller number. So I will demonstrate on the calculator. So I'll copy and paste this number. So I'll do 6, which is my last guess. I'm doing this part right here to get a new last guess. 6.5 divided by what our last guess was, or what our next guess was, which is that, or actually I messed up. It's a last guess plus next guess. So 6.5 plus our next guess, which is that, divided by 2, is our now new last guess. So I'll go ahead, it'll keep on repeating the same. So last guess is now this number, and next guess will be the number 12 divided by this number. So I'll go ahead and do that. Control C, 12 divided by our last guess is 2.8, and as you can see, these numbers keep getting smaller and smaller and smaller, and eventually come to a point where they're close enough to 10 thousandths of a number that it will just take whatever last guess is and keep that number as our answer to the square root of the number. So I feel like I have explained it a little bit. Don't know if I confused you. I hope I didn't. But we'll go ahead and run our code and see if it is close to what the actual integrated math square root function gives us. So I went ahead and used a print statement and my function that I made up at the top. Give me 1 second. Boom. Up at the top, and use the integrated math function down at the bottom to see what kind of differences we see using the Babylonian custom method or the math integrated method. So I inputted the number the homework stated to try. Do it with 12. I believe it says 12. Let me check. It actually doesn't give a number, so we'll just try with 12. 12 sounds good. So we'll see 12 if 12 has a perfect square root, or what number the square root of 12 gives us using our method or our function that we defined and the math imported function. Let me run this really quick. And as we can see, using the custom square root function right down here, we get that the square root of 12 is this number right here, 3.464106533502986. And using the square root, or using the imported square root function with the square root of the number 12 is 3.464101615377544. So they are very, very, very close. I would say this would be a feasible answer, because normally, I don't know, if you're doing math, you would take maybe the rounded part 3.46 or something like that. But we'll go ahead and try with another number, see if our function is correct with other numbers. So we'll try with 15. I'll go ahead and run the code one more time. And as we can see from this to this down here too, they're very, very, very similar. It is until the 1, 2, 3, till the 7th decimal place that they start not matching, which is really good, I think. So, as I demonstrated, my 3 homework problems, I did have code that worked, and I believe they worked because I followed references or had resources that showed me the things that I needed and followed the steps. I have provided enough examples to where I believe that most of you will be, or will trust in my code. But other than that, that's all I have. Thank you for listening. Goodbye.